right. This is being live streamed now. This week's lab, determination of the percent of phosphorus in Miracle Grow fertilizer. There's a few announcements that I need to make first. And there's just some stuff Dr. Christopherson sends emails out to all the instructors and just very basic things. First thing, don't stay late for lab. Students apparently aren't coming prepared, and several times people have to stay afterwards. Thing is, my sections are the best. Promise you guys. I don't think we've had anyone stay past, when do we end? 3:50? And the nice thing is, like, maybe someone has been cleaning something up to that point, but I think everyone gets out on time. You guys do a great job, so just keep it up. You're getting yourself prepared and you know what to do when you come to class, so thank you. And the tips that are given also is read the lab several times and start cleaning up 10 minutes to the end. And that one I do know, I do pay attention because some of my TAs have classes at 3. So that one, no one has ever been still doing chemistry at 2:40 p.m. Everyone's been done and cleaning up. And so you guys are just doing a great job. And in general, I want you guys to struggle with the chemistry, not with the cleaning. And so, I have no problem helping you clean, but during the first part of lab, I want you to stay on topic, stay on task with the chemistry, and don't worry about so much the dishes that are going to be done later. Just crank out the chemistry, crank out the stuff you get points for. And worst case scenario, you put away some dirty test tubes, and when you need them again, you'll have to clean them. But I'd rather you get all the points you can for the lab and put away some dirty glassware than to be cleaning up glassware in the middle of lab and then run out of time to do the stuff that you get points for. Okay, other things. This week, we are working in groups of 3. Everyone's going to get unique unknowns, and that way they can't get compared. And if we work in groups in 3, the largest section is 27 students. So that means there's going to be 9 groups. And with 9 groups, we got 9 hoods. And I'm not sure how I'm going to do this right now. I might just go down the aisles and be like, you're a 3, you're a 3, you're a 3, you're a 3. Because you already seem to be talking to the people next to you. Or I might get a whole bunch of popsicle sticks and put all the different numbers 1 through 9. I don't know. Pass them now. I don't have time for that. We'll figure something out. But I don't know if it's going to be random or if it's going to be semi just work with the people close to you type of thing. Unique unknowns, you need to weigh out 1 gram to the nearest milligram. Basically what that's saying is you got to take all the sig figs from that digital balance. There's going to be a decimal point and then 3 numbers after it. You got to take all 3 numbers. So you got to have a 1 dot 3 numbers. That's what it's saying there. And since your unknowns are all unique, you can't compare them to other groups. Oh, new lab report sheet. So it basically has the same things. I haven't seen it yet. It's going to have the same things as the current lab report, but it's going to have a spot for your unknown number because everyone gets a different unknown. So you're going to have to record your unknown number. And Dr. Christopherson says there might be 1 or 2 extra questions. I don't know what those are yet. So hopefully they're not too scary. You need to turn in your lab report with your partner's names. And there's a stapler. Why not just staple them together too? Not, put your names on because when Tosa grades them, she might rip them apart. But thinking of the person who's going to be grading this, it'd be nice if all of a single group were stapled together and then you just rip them apart later and it's fine. That'd be my advice. It's 9 safety hoods. I am setting up your filter apparatus. Don't worry about the setup because I want you to struggle with the chemistry, not with the hoses and the vacuum pump. You do need to make sure that things are clamped so they can't tip. If anything is wiggling, then yeah, just clamp it down more, or come get me and I'll make it so it can't wiggle. But you're going to be working with it. You don't want it to like tip over and spill everything. So even if I've set it up, make sure nothing wiggles, nothing can wiggle free, and you'll be fine. At the end of lab, you're going to rinse your flasks and your funnel since they're being used by all the different lab groups. And rinsing, the easiest thing is a triple rinse. This is so common in chemistry. Rinse something 3 times. Like the first time you take off 99%. I'm sort of making up these percents, but you take off most of it. Second rinse, you're going to take off 99% of the stuff that was left. Then the third rinse, you're going to take off 99% of the stuff. And so like it just keeps getting more and more dilute with every rinse. And so just a general rule of thumb for cleaning anything is you can rinse it 3 times in anything that it is soluble in. Doesn't necessarily mean water, because sometimes we're working with insoluble stuff. So if it's soluble in acid, you can rinse it 3 times with acid and it'll be clean. If it's or organic, like sticky, grimy substance, that's where like the acetones and the alcohols, you could rinse it 3 times with that. That's a tangent. Sorry for making this longer than it needs to be. And yep, so in this case, stuff's going to be water soluble for the most part. And so you just got to rinse them 3 times with water. And since you're going to be working in the hoods and spread out your glassware somewhat, you're going to be groups 3, you're going to want someone's glassware. I would recommend, since these drawers are just typical drawers, and I can help you because if I drop your drawer, I will not be charged for all the stuff in your drawer. But if you drop your drawer, you will be charged for everything in your drawer. So it might be best for me to move the drawer, or the TA. We can both be blameless. But the drawers are easy to come out. Do a little hop at the bottom. You take the whole drawer out. We can then set the drawers right behind you on the fume hood. Your fume hood's going to be on the wall. Your drawer of glassware will be right there. And I think that'll just keep things simple. That way, especially the people in the middle rows, you're not going to be like wandering all the way over there to get your glassware a whole bunch. I want things to go fast. I don't want you to be walking. I want you to be doing chemistry. So we're going to move your drawer. But if you're comfortable with it, just do it. It'll simplify things for me. So I don't have to do it for everyone. But if you're worried, I can do it. All the ways can go down the drain. And we're going to, there's going to be ammonia. Since all the hoods are currently claimed by a group, I'm not sure if of those 9s, the disability hood is. That's the one that actually can go lower. If that's one of the 9 that they're including, or if there's still a hood for waste and chemicals. But if that is taken, then all the hoods are taken and the chemicals can't be stored in the hoods, so they'll be on a bench. But specifically for the ammonia, we don't want that open out in the room. It will burn your nose hairs. In one of my past videos, I mentioned wafting concentrated ammonium hydroxide, and man, that thing dropped me to the floor. Good thing it was a plastic bottle, but it will burn your nose hairs. It'll clean your sinuses so well. You'll have nothing in there and you won't smell anything for a long time. So only open these 2 molar ammonium hydroxide bottles in your fume hoods. And there's also a recent video that I put out that's actually going to be relevant to this. How ammonia and ammonium hydroxide are basically the same thing. So maybe go find that supplemental video and you'll understand how ammonium hydroxide and ammonia are the same thing when you've got them in a bottle. We're going to do all this setup, all this stuff. We're going to put stuff on a vacuum pump for 25 to 30 minutes. And, that's going to be boring time, perhaps. I'm trying to picture how lab will go. I think that would be the best time to work on calculations. Now you're going to be like, Jonathan, we don't know the final mass. How are we going to work on these calculations? We'll just pick something. I might put like a practice number on the board, be like, if this is what stuff weighed, what would your final thing be? And if you can, as a group, work through the calculations on this example value that I give you, then you'll be great. In fact, I've got an example value right here because I did all the calculations myself to test it out. And if you can work through all that during that 25 to 30 minutes and get the same answers as me, you should then feel comfortable knowing what to do when you get to your unknown. Now, a very key thing that Dr. Christopherson said is don't give molar masses to any compounds to the students. And so before making this video, I went through all these calculations. I'm going to help. I'm going to show them how to do all these calculations. But these calculations are very heavy on molar masses, molecular weights of specific compounds. And I realized that I can't walk through them quite so perfectly anymore, because then you'd have all your answers for some of those things. But that's why if I use that 25 to 30 minutes when you're vacuum pumping, you can then use that time to practice, to calculate things, to see if you get to the same final value as me. And if you do, feel comfortable when you get to your actual unknown. So that was the notes that I've been given. As for the rest of the lab, we're just determining how much phosphorus is in something. And honestly, if you don't know what to do with your career, become a chemist. Like, this is the type of stuff that makes good money. My first job out of my undergrad, I got paid really well with unlimited overtime. And all it was quantitative analysis. That's what we're doing. This is very quantitative. And in so many industries, there needs to be quality control. How are we staying within the parameters of everything that we're doing? And I worked in a lab that analyzed gas samples for oil and gas companies. And yeah, like, this is such a good route of money to work if you want to work in a chem lab and just doing very simple stuff. It's very fun in industry. And so I'd recommend it. Lots of jobs to be an analytical chemist. Hopefully you'll get converted. Now, in general, we are just looking at the phosphorus content, and we're going to do this with gravimetric analysis. That just means we're going to weigh it. We're going to dry it and weigh it. On the front, it gives you a breakdown of what is happening. Now, if you look at the questions, now these aren't going to be the exact questions that we're using. Question 13, a label on a plant fertilizer shows 15, 30, 25. What does that indicate? That's right there. And that information comes from this first paragraph here. So just keep that in mind. And it goes through this NPK ratio, 24, 8, 16, and the ratio indicates that the fertilizer contains 24% nitrogen, 8% phosphorus as P2O5, and then 16% potassium as K2O. Now that as P2O5 is actually important. I didn't catch this the first time, and when I did my sample calculations, I got something really funny. I practiced with my 1 gram doing the calculations, and I was trying to predict how much mass I should have on my filter paper, and I was just using straight phosphorus, just P. And when I got to the mass on my filter paper, it said that my 1 gram had turned into 20 grams. And I was like, just thinking, it's kind of impossible to fit 20 grams onto my filter paper. And what I ended up realizing is meant by this as P2O5 is that truthfully, you will not have 8% phosphorus, like the single element, make a P. You won't have 8% of that. It will be less. And that's because they're only saying you have 8% P2O5 in your fertilizer. That threw me off. And so I want you to realize the actual elemental phosphorus will be less than that 8%. And then all my calculations worked out. I no longer had 20 grams on my filter paper. I had like 0.2 something on my filter paper, which, 1 gram to 0.2 makes a lot more sense, especially when only 8% is supposed to be that. And I use that 8% there. So keep that in mind, that you need to convert from 8%, which would be 8 grams of P2O5 per 100 grams of fertilizer, to using the molecular weight of P2O5 to moles, and then so on and so forth. What's it called? Phosphorus pentoxide. All right, so then they walk through that 10% magnesium sulfate and 2 molar ammonium hydroxide. Now, I did do some calculations, which I think I can walk through. Let me make sure. Where's it? Sorry, I wish I had editing ability and could pause the video and help you out with these things. So a couple calculations I did was, what is the molarity of 10% magnesium sulfate hexahydrate? And it came out to be 0.006 moles. And then what's the molarity of, or how many, let me get this correct. So we take 15 mils, sorry, I wanted to know the exact amount in there. So we take 15 mils of this magnesium sulfate and put that with our 1 gram of fertilizer. We also take 15 mils of ammonium hydroxide, 2 molar. And I want to know the exact number of moles, because it's not so much the mass and things like that, but it's particles crashing together. And so that's more what it has to mean when it comes to balancing things. And so what I found out was, in that 15 mils, you're going to have about 0.006 moles of Mg2 plus. You're going to have about 0.03 moles of NH4 plus. And then from the phosphorus, 0.003 moles P. Right. And these are the number of moles, not molarity, not concentration, but the number of particles. You could take these, multiply them by Avogadro's number, and get an exact number of particles. Now, what's interesting is the fact that the final formula for the precipitate that we are making is MgNH4PO4 6H2O, and it's a solid right there. And what's the ratio that these things are in? Well, for every 1 magnesium, you have 1, we're talking about this whole subunit here, and we have 1 magnesium, 1 NH4, and 1 phosphorus. And so if we talk about limiting reagents, essentially it's like, what is the limiting factor? It's your phosphorus. It's the thing that you have the smallest number of particles for. And so we've talked about quantitative and qualitative things. Your fertilizer, you better get a very precise number, because this is your limiting reagent. This is the thing that is going to determine everything else. Because like, once you're out of this, these other things, they're just going to bounce around. They're not going to do anything that really affects anything. They're not really purposeful. So, because everything's in a 1-to-1-to-1 ratio, this is what limits it. This is quantitative measurement right here. These are qualitative measurements. They say 15 mils. You should do 15 mils, but don't worry about like even a 10% error with that mil there, because it's a qualitative number, not a quantitative number. So just be fast about that. Don't worry about being perfect with those numbers. They're in excess. And if they don't do anything, they're just going to bounce around. And so we're going to do that to dispense it. Medicine dropper. to dispense the ammonium hydroxide. This was interesting. I did a little bit of searching to figure some things out. And whenever you drip something in slowly, there's a little bit of a reason for that. And what it is there's a chemical reaction occurring and you're forming a precipitate. And if you dump it all in there, there might be some side reactions and the precipitate might not form and you might not get it to all come out. So you want to add it very slowly so that the first little like particles that start to solidify, they're going to aggregate and grow like a snowball. Like if you've had that really nice wet snow outside to make a snowman and you start rolling it and the ball just gets bigger and bigger and bigger. Well, that would be essentially what you're doing. When you're adding it slowly, you're letting them keep adding to that same snowball. Whereas if you add it in really, really fast, that'd be essentially like just starting, like taking a whole bunch of clumps and making a whole bunch of snowballs, but never really rolling them, never giving the time to like add to the same chunk. We're going to filter this later. So if you want good results, adding it slowly, one of the labs that I read actually said, like add it over a 3-minute period. And is that this one? I don't know. This is a comment that I found out. Add it over a 3-minute period. That's pretty slow to be slowly adding your ammonium hydroxide. And that will give you bigger particles in solution, meaning when you filter, you're going to get more on your filter paper. More on your filter paper will mean you'll actually be measuring it. If stuff goes through the filter paper, you won't measure it. So when it says add it slowly, do add it slowly. And just for a possible time range, try adding it over a 3-minute period instead of just like, it's in. While stirring this mixture with a glass rod, swirling, it just needs to be mixing. People are breaking glass rods, but I mean, they're cheap, so I guess it doesn't matter too much, but just make sure it's mixing lightly. Then leave the beaker in the safety hood to let the precipitation complete for 15 minutes. That again is just making sure that instead of having a whole bunch of really small snowballs, we get some big snowman chunks, giving it time. While waiting, set up the vacuum pump. It should be already filled up, set up. All right, now this is important. So this is going to hopefully prevent you from having problems. I've seen this so many times, especially in organic chemistry. We had this problem all the time. I don't want you guys to have this problem. The way your Buettner funnel works, I'm going to do a side view. It's got walls. It's got this flat part here. And this flat part has a whole bunch of holes in it. And then the funnel comes down. And then it drains into whatever. And right around here, there's going to be like a rubber seal to make sure that there's vacuum. But the filter paper is going to perfectly fit on this area here. If it is off skew a little bit and there's a hole visible, liquid's going to take the path of least resistance. It's going to go straight through there, meaning a lot of the solid's going to go through there. So when you put this filter paper on, you need to make sure that it's sucking itself really down. And the lab goes through putting a little bit of liquid on it to make sure you can just spray some water, like use one of those squirt bottles, I think. After recording the weight, stir the contents, and okay, so you're wetting it with isopropyl alcohol. That's fine. But you're going to wet it with isopropyl alcohol so that it sucks itself onto there. Now here's the other thing. If it gets too dry, it might start curling up on the edges. If you pour liquid too forcefully, then this might jostle it and scoot it to the side, meaning stuff will bypass the filter and end up in the solution below, and you won't be weighing it. So when you put it on here, really aim for the center and try to go slowly to not necessarily disturb the filter paper and expose those holes, because the filter paper is the only thing blocking those holes from sucking your stuff straight through. Worst case scenario, something gets just jostled and you see liquid in your Erlenmeyer flask at the bottom. It's a really simple fix. You just have to disconnect things, take that Erlenmeyer, pour it into a beaker. We're going to do this quantitatively because we want to save everything. So you'd want to rinse that beaker 3 times and transfer that liquid also, or rinse the flask 3 times and transfer that also into the beaker. Then you're going to set it up, and then you're going to pour the stuff that went through back on the filter. At max, do this once. Don't sit there and refilter the filtrate 3 times. Like, you're diminishing returns at that point. It's like you mowed your yard once, you mow the yard twice, maybe it makes it a little better. If you mow your yard the 3rd time, there's really no point in mowing your yard 3 times on the same day. So same thing with refiltering your filtrate. Only do it like if it's very obvious that stuff went through and you want to do a good job. So all's not lost, but initially just make sure that filter paper does not move. And then after that, you're going to rinse it with isopropyl alcohol. Isopropyl alcohol evaporates faster. And so we'll put it on there. Again, when you're putting the isopropyl on there, the vacuum is still running, and we don't want to disturb that filter paper and cause it to move and cause the solid stuff to go down. And so, don't use like a super soaker to pour on the isopropyl. But you want to put the isopropyl on there because it's going to take the water away. The more you take the water away, the less time it's going to take to dry. So, be pretty liberal with your isopropyl alcohol in rinsing it. It says 3 squirts. It doesn't really tell a volume, but the more you squirt it, the more junk you're going to take away, and the more water you're going to take away to speed up drying, and to make it when you weigh it, you're not weighing the massive extra stuff that didn't react and things like that. The salt that we made isn't going to be very soluble in isopropyl, so it really should just stick to the filter paper. And then allow it to dry for 30 minutes on vacuum suction, then weigh the filter paper and the dry precipitate and determine the weight. So it's pretty straightforward. I think that you're all going to be very, very successful, and it'll teach you some new stuff. Now, as for the things that could go wrong, we've already talked about the filter paper moving, meaning you'd have less product, which means you would have a lower number. The other thing that can go wrong is you don't let it dry long enough. So if things don't dry long enough, what would be the result in that? The mass you weigh is going to be heavier than what it should be. So you can sort of think like there's this perfect mass. Like if everything works beautifully, this is the number that I should get. If I lose my product, then I'll measure less. If I don't remove all of the other products, then I will measure more. What would that look like? Well, if you end up with like over 100% or something. Now for this, we're already using a small amount, so I guess you wouldn't have over 100%. But yeah, if you weigh a wet filter paper, the mass will be higher, which means it will arbitrarily inflate it. How can you check to see? Well, you can put it on a watch glass. It might be nice to weigh your watch glass. In fact, one of the other labs that did this said to weigh the watch glass, weigh the filter paper, and weigh the precipitate. And that way, the watch glass is a little bit easier to carry around, especially since you're going to be carrying this filter paper with the stuff on it to a balance. Stuff could blow off. The filter paper could blow off. You could drop it. You'd lose product, and you'd be sad, essentially. And so to prevent that, it might be really, really nice to actually weigh your watch glass. You'll also have to subtract that weight later and weigh your filter paper. And then when you finally do stuff, you'd weigh the filter paper on the watch glass with your precipitate on it. That should simplify things and make it so that you don't have to worry about stuff falling and dropping and things like that. But getting back to how do you know if it's dry? Well, when you weigh it, go back, set it in your hood for like, a minute, come back and weigh it again. And if the mass is still dropping, that means evaporation is still occurring, which means it's actually not all the way dry. We don't really have unlimited time, so we just have to do the best we can. And my guess is if there are going to be errors, then they're going to be that things didn't dry enough and your masses are heavier than they should be. I haven't done this lab, so I'm not sure if 30 minutes is enough time to drop, but that's one way to check, is something fully dry? You weigh it, wait a minute, weigh it again, and if the mass is the same, then it's dry. If the mass has decreased, then it's not dry. And yeah, so that's the end of that. As for the questions, I have a whole bunch of stuff that I filled in here. And again, I think I'll use that for a practice calculation, which you guys can work through during the 25 to 30 minutes when you're vacuum drying and see if you can get the same things as me for the percent. And I just used an 8% mass and 1 gram mass. In fact, this would be a really good thing, really good thing to do before coming to lab. At the front, say you have an 8%, say you have this where it's got 8% P2O5 in the mix. Say you weighed out 1 gram. I want you to practice calculating how much you should see on that filter paper. So again, weight of fertilizer sample, 1 gram. Weight of filter paper, just say it's 1 gram, just to practice this. And then I want you to calculate how much you would expect to be on that filter paper. And that's where, when I was doing that, I ended up with like 20 some grams. And I'm like, that doesn't make sense, putting 20 grams on a 1 gram filter paper. No, that's not going to happen. And then I realized you have to account for the fact that there's some things in there. But try that out, please. And if you can figure out the mass that you should get, if you have that, you'll be in a really good place, because that'll actually be a good practice, because you'll also have to pre-calculate the molecular weight of the MgNH4PO4 6H2O, because I'm asking you to like figure out like what would be the mass on your filter paper if everything got transferred 100%. And you have to figure out the molar mass of P2O5. Now, we'll be doing that in lab. And again, as always, don't come with things pre-filled in on your lab report, because in theory, you could have gotten questions and answers from another person, and we don't want to see that in lab. So if you do these practices, don't do it in the lab manual. But it'll be really good practice. 1 gram sample, how much, what mass would I see? A 1 gram sample, 8% content in the fertilizer. What would be the mass of MgNH4, PO4, 6H2O on my filter paper? And I have a little note here. There's a wonderful YouTube video of someone who was sort of explaining this. She's like, I'm not going to call this by its name anymore. I'm just going to call it salt. And that's really what it is. So if you really just get tongue-tied, just cross out all that and just put what's the salt weight, because that's what the precipitate is. It's a salt. So molar mass of salt, weight of salt, etc. And then calculations, and then yes. So I think that is everything. In addition to this video, I'm going to possibly put some YouTube links to other people that have gone through this. There's a really good video, and I'll have it be the first one in addition to this YouTube video that I have, where they just visually go through what's happening. And it was recorded in 2020. So I'm guessing it was a lab instructor who was like, how am I going to teach this lab to students when they can't come to lab because of COVID? And he just sort of had a camera, recorded himself going through the steps. And I think that'll be very good just to visually see what the steps are, so you feel comfortable when you come in. It doesn't go through the calculations and things like that, which is fine because you guys need to figure them out. And then, as always, for the quiz stuff, I want you to be prepared for lab. That's what the quiz questions will aim for. What does being prepared for lab mean? It means being safe, not dying, not getting hurt or anything like that. But then it also is, what do you need to know to get the most points on the lab report? And so if you keep those two things in mind, you can know that I'm not going to ask you arbitrary things about procedure. I will want you to know things In this case, it's a lot of calculations. I want you to know, be comfortable with these calculations. How can I do these calculations? I want you to know how to calculate stuff and be safe. If you do those two things, you guys are always the best students. I have a fun time with you. So have a good night. I have no idea how long this